Right now, we have the next person is coming, second time on the blue stage in 2 years. I have pleasure to announce that we have Viktor Farcic from Serbia, Barcelona, both things. And he is a developer advocate at Upbound, a member of the Google Developer Experts, CDF Ambassadors, and GitHub Stars group. And he is also a published author. So please welcome on stage with a warm applause, Viktor Farcic with How to Fight Misconfiguration and Bad Intentions with Kubernetes Validating Admission Policy and Crossplane. The stage is yours.
Okay. Oh, I don't have a clicker. Okay, I'll have to be here. Cool. So you already heard who I am and stuff like that. I'm going to skip the introduction right away. I'm going to skip the setup and talk about Kubernetes admission policies. Before I actually do that, I want to touch briefly why do we do that in the first place, right? Why do we want Kubernetes to validate something? And the answer is relatively simple, because it's a single place where you need to do stuff, right? If you would like to apply some policies for security reasons, best practices reasons, or just to help people not do silly things, and you would like to do it somewhere else, that would probably mean that you would do it in, let's say, CI/CD pipelines, right? Or, but then you have a problem, okay, I need to apply to make sure that everything is correct in hundreds of pipelines. And then you need to think about how am I going to prevent people from doing silly things when they connect to their clusters from a laptop, right? And so on and so forth. So it's very, very beneficial to have one place, you know, or multiple places if you have multiple clusters, but still a limited number of places where you know that you have policies that will enforce certain things, whatever those certain things are, right? That will depend on you. So since almost very early, almost very beginning, Kubernetes has something called admission controllers. Now, for those of you new to Kubernetes, let me briefly explain how that works. So when you send a request to Kubernetes, hey, I would like to have this deployment, for example, or whatever that something is, it goes to Kubernetes API, and then from the API, first it goes through rollback access control, RBAC, meaning validates whether you are allowed to do that something or create or to have that type of resource or know in that specific namespace. And then it goes through admission controller mutations. Those are special admission controllers that there are no mutations available in Kubernetes, actually, but they fire webhooks to other tools that might modify your manifests. And most of the time, that's actually silly. You shouldn't be doing that. But there are some really, really good use cases for that. Like if any of you is using Service Mesh would add sidecar containers to your applications. And the way how it does that, by modifying the manifest of your application and injecting additional things like sidecar containers that will manage your traffic, right? Or you can use something like Caverno that will do something similar, except that instead of predefined mutations that come with, let's say, Istio, Caverno, you can define, hey, let's say, if somebody forgets to put resource requests and limits, then I will add some default values and say, if you don't say anything, I'm going to assign you 1 GB of memory, right? So, in other words, it can mutate your resources before they even become something in a cluster. It can modify them, and you're in control of what those modifications will be. Then it goes through object schema validation. Validation cannot happen earlier than this, simply because first you might need to modify something automatically, and then it will validate whether that something, that resource, complies to the schema of that resource type or resource definition, right? So is it okay? Can this even work somehow in Kubernetes? That's what it really does. And if it is okay, comes to the main subject, main part or topic of this story, and that's admission controllers, right? Those are controllers that until recently, all they would do is fire a webhook to yet another set of tools that will validate whether you can do something, right? Are you allowed to create this resource in this current form or not, right? And it can either enforce that something, meaning that you're not allowed to do that in the first place, or it can be just informative, like a warning. You shouldn't do this, but I'm going to let you pass through anyways. Now, only after all those admission controllers are passed, it is stored in etcd, which is kind of database for Kubernetes. That's where all the information is stored. And only after that, something is created, right? That something can be, again, anything. It can be a deployment, which creates replica set, which creates pods, or service, or ingress, or whatever that something is, right? And that can happen either by, all this process happens either because you chose to apply something, or because whatever you're creating will create additional resources, right? So if you say, I want a deployment, then it goes through this whole process, and then Kubernetes says, okay, but I should create a replica set for that deployment, and it would repeat the same process over and over and over again, right? For every single resource. Now, and then in 126, which is, I think, 4 months ago or something like that, actually, before I go there, all this, none of those things are actually mutations and validations. They were not baked into Kubernetes. Kubernetes just had a mechanism to notify other tools that will do those things for you, right? Now, since recently, 4 months ago, give or take, we got something called Kubernetes Validating Admission Policies, which is Kubernetes baked-in way to create policies in any way you see fit, right? To define what is okay and what is not okay. Now, you cannot still use it in majority of Kubernetes clusters because it is in alpha stage, and not long ago, Kubernetes changed the policy. Only things that become production, like V1, are baked into Kubernetes, so you would need to enable it yourself. Or you might want to wait until it is production ready, but it's there, right? That's what really matters, and we should start preparing for that. Now, this is an example of validating admission policy, which essentially says, actually there are 2 parts. This is the policy. You will see the second part later. It says, hey, if you ever create something in API apps v1, if you propagate to API something that is apps v1 API, and if the operation is to create or update that something, and if that something is a deployment inside of that API, then apply this validation, right? And validation is relatively straightforward. It says, this is okay. Whenever you create a deployment or update a deployment, it is okay just as long as the number of replicas is less than or equal than 5. Meaning, if you put 6 replicas, it shall not pass, right? It will never reach etcd, and it will never be created in a cluster. And that is accomplished through failure policy fail, right? Meaning you cannot do this unless there is 5 or less replicas in a cluster. And then we have policy binding. So policy does not do anything by itself. It just exists there. And then policy binding is a way for you to say, okay, I want to apply this policy in those circumstances, in those situations. And in this case, it is applying the policy that I created earlier whenever there is, to all the namespaces that have the label environment set to test, right? Or whatever criteria you want. It's up to you to define the criteria when that something applies. Now, that sounds easy, right? It's extremely easy. You just define a policy, you define binding when that policy applies, and that's about it, right? Now, it doesn't really work. The whole concept of admission policies does not work in Kubernetes if you use Kubernetes as is, right? If you don't do some additional things in your Kubernetes cluster. And I will explain why through an example. An example will be that I will deploy an application to my cluster. Nothing special, just a silly application. There is a config map, a secret, a service, 2 services, 3 services, a deployment of my application, a stateful set, which is my database, Postgres as a Helm chart, and ingress, right? This is everybody's applications are going to be more complex than this. Just to clarify, this is kind of hello world with a database. Imagine hello world using a database. That's the level of application I'm having right now. And what I got is this, right? This is now running in the production namespace. Again, those same things. Some 15 resources all together, one way or another. Now, a pretty drawing of what I did. Nothing really special. And I repeat, you will have more than that. Certainly, you will have more than that. Now, let me delete that, and because I'm cheap, I don't want to waste money on you. So, it's still easy, right? All you have to do is for all these resources to define policies. You will define a policy. How can a service look like? How can a deployment look like? You can skip replica set and pods because they are created by deployment. You will have a third policy for stateful sets, fourth for config maps, secrets, and ingress, right? 6, 7 policies, it's still relatively easy, right? Except that there are 6 policies. Actually, there will not be 6 policies. There will be 6 policies multiplied with all the variations that you might have, right? You will have policy for the number of replicas of deployment, policy for this, policy for not having enough resources allocated or not having resources, memory and CPU allocated at all, and things like that, right? So you will probably, for this silly example alone, end up with, like 50 policies, 60, something like that, right? It's still doable. It's still humanly doable to do that. Now, what happens if you install additional tools in your cluster, right? You might install Argo. Argo will extend Kubernetes cluster with applications, application sets, projects, a few other things, right? So you will write 5 additional policies multiplied with all the permutations that you have in those resources. Maybe 50 more policies, still doable, right? You will install Knative, and Knative will bring you a bunch of things because it will probably come up with, it will assume there is Istio, and then you will have for Istio another 100 policies, and so on and so forth, right? And you go crazy with Crossplane, and you get thousands of custom resource definitions, and you have zillions of policies. And in this case, this is what I have in my cluster, right? I have a bunch of custom resource definitions that do stuff, whatever the stuff is, and I would have to create policies for all those. Let's say, on average, 10 policies per resource. So you do the math. This is 600 resources times 10, 6,000 policies. Still doable, humanly doable, right? Now, even if you do all that, there is a problem. And the problem is, in a way, how admission controllers work. And admission controllers work on per resource base, right? So every single resource that you submit to Kubernetes will be validated by itself in isolation, right? So you say, OK, I have a deployment, I have a service, I have ingress, I have this and that. It goes, OK, what came first? Deployment, OK, not OK, service, OK, not OK, and so on and so forth. And let's say that one of those resources is horizontal pod autoscaler. Actually, let's take a look at this example. This is the same one as before, or very similar one, right? The one that says you cannot have more than 6 replica of an application, right? Easy, straightforward, what can you do? Now, the problem is what I mentioned before, context. Meaning that this deployment or validation of a deployment does not do anything by itself, right? It's combined with other resources, and I could have, for example, horizontal pod autoscaler in my cluster that will automatically be changing the number of replicas of deployment depending on metrics from Prometheus or something like that, right? So if I use this policy, and if I tell Kubernetes, create a deployment, and you know what? I'm not going to even specify a number of replicas. It's going to be the default value of 1. So this policy is completely valid. I can create that. And after that, horizontal pod autoscaler will come and say, yeah, but I'm going to create 100 replicas. I'm going to modify deployment to create 1,000 replicas of that application. And it's all good. I mean, it would fail, but you would never find out that it failed because you would not be, by the time, at the time that you actually created this deployment, you would think this is working perfectly fine. You will be wondering what's going on later, but not at the time you submitted this to Kubernetes cluster. So, faced with that, the only reasonable way to manage policies is to give them a context, meaning to create a resource that will have all the information of everything that is required for something, for an application, right? So to create an abstraction of top of all those resources and say, okay, so this is something called X, right? Application, my application, whatever that something is, and there are some fields like number of replicas and this and that, and behind the scenes I will use horizontal pod autoscaler or CADA, or maybe I will put the number of replicas directly. I will manage the resources for you, but the only way for you to enter the system is to create that abstraction. And that's what I will do, right? I have this manifest, which if you came yesterday, you saw something very similar. That instead of me creating 57 different resources directly, and each of them having policies applied independently of each other and not understanding the relation between them, I'm going to create a new abstraction and say, this is how we deploy applications. You can select namespace, image, port, host, whatever that something is, whatever we agreed. And as a result, behind the scenes, I will have a controller that will create horizontal pod autoscaler that will scale your application. It will create service mesh or virtual services for that application, and so on and so forth, right? But if this is your only entry point to the cluster, I have all the context I need, right? Because this resource is going to create everything that it needs. This resource is verifiable, unlike other resources that cannot be verified, validated properly without the context of all the other resources it depends on. So, this is what I'm going to do, right? Instead of creating all of those resources separately, I'm going to create a new one, new resource definition in my cluster, and let that resource be validated, and let that resource, through its controller, create all the stuff that it needs to create. I'll be using Crossplane, but that's not really relevant for this story because you can actually, you can do that with many, many other tools, right? You can code it directly if you want with whichever framework you choose. You can use MetaController, which helps you create resource definitions and controllers yourself very easily. You can use kubevela, for example, which is great if you want to define something yourself, and so on and so forth, right? So many different tools. I'm using Crossplane mostly because that's the project I'm working on, but not because I'm selling it to you today. Now, so what I created, you can ignore this secret for now. I chose to create a database in this case, and database will have a bunch of resources in Kubernetes, whatever those resources are. But from the policy perspective, all I have to validate is that that thing called SQL claim is valid, right? That it can be, it is allowed to pass. Behind the scenes, I got all this, right? Behind the scenes, this single resource created subnets and VPCs and internet gateway and route table and routes and so on and so forth, right? A bunch of stuff was created in Kubernetes cluster, but from the policy perspective, the user just created something called SQL claim. Now, this is essentially what I'm aiming for, right? And again, you can replace the word SQL here for application or front-end or back-end or whatever you're doing. Doesn't matter what it is. What does matter is that I'm doing two things. First, which is not the subject of this talk, I'm simplifying the life of this guy. Instead of creating all this stuff that he can create or she can create a single resource that will expand into everything we need. And at the same time, not only that his or her life is easier, but also I deny permission for he or she to create any of those things directly, right? So I know exactly what somebody can do. I have a single point where I can validate whether that's okay or not okay, instead of going through pipelines, terminals, and this and that. Somebody's life is easier, and my life is easier because I have now a decent way how I can create the policies that I need. Now, this is the example that I run. This is not important. What is important here is this definition, right? And this is, again, this is baked in Kubernetes now, if you enable it. It's alpha, right? I have admission policy to begin with that says, hey, if you create or update something called SQL claims or SQLs, custom resources, this parameter size must be small, medium, or large, right? Those are the acceptable values. Anything else you might put there will not pass, right? And I'm binding that policy, the second resource. I'm saying, OK, this policy will be applied to all namespaces that have the environment label set to not being silly, right? So any namespace that doesn't have the environment label silly will receive this, this policy, right? Which is in this cluster, in this context, if I'm not mistaken, every single namespace, right? So it applies everywhere. And I have a second one that says, OK, this is similar to the previous one. The only major difference, there are two major differences. First, policy that applied to whole cluster could allow the size of the nodes to be small, medium, large. But in this case, it can be only medium and large. Those are the only two acceptable options in this specific case. And the version of Postgres in this case must be 13 or 14, which is regular expression. You figure it out. Now, and this policy will be applied only to the namespaces that have the environment label set to production, right? So in other words, you can do almost, you can have small, medium, or large databases anywhere you want, but if it's production, it must be medium and large. And the version of Postgres cannot be anything but 13 and 14, right? Now, again, this is all custom. You create whatever you want. Just an example, right? Now, if I apply this, it works, right? Because I did not explain, but here you can see that what I applied is small. That works. And we already said that in all namespaces, I can do whatever you want as long as this parameter size is small, medium, or large. So this works fine. Now, if I apply exactly the same manifest, exactly the same thing as before, the only difference is that I'm going to apply this manifest to the production 2 namespace, which, by the way, previously already defined in that namespace label production to be label environment to be production, right? In this namespace, I cannot do it, right? Because it does not fit the second. It fits the criteria for binding a policy for that namespace, but it does not fit all the validations. And I'm getting information that, hey, size must be medium or large. I defined it as small. Here, I shall not pass, right? And that's how it works. And I'm 15 minutes early. We have a lot of time for questions. Or not. Or you can remain in silence forever and ever. I don't have any more slides. No. Cool. Could someone validate? OK, is it you reading? Go ahead.
1 second. OK, now I have mic. So thanks a lot, Viktor, for the presentation. And now I would like to encourage you to go to Slido and have a 15-minute discussion with Viktor. Rare, but nice. So let's start with the first question. There's also a control screen here, so you don't have to go back.
Look, modern technology is always surprising me.
So can you easily monitor which of these policies are failing or have failed, like the way with
So it depends how you define policies. If they're set to fail, then those shall not pass. You will get exit code, non-zero exit code whenever you apply kubectl, execute kubectl apply or helm something or whatever you're doing, right? If it's set to, I believe it's warning. I rarely use the formative one. It shall pass, but then in the resource of the policy itself, you will have the information why you shouldn't do that, right? So fail with fail it will not even create those resources in a cluster, and if it's warning, if I'm not mistaken, or something like that, then it will just notify you of the issue.
Cool. Second question, could someone validate the policies also in CI prior to applying the manifests in the cluster? I'm thinking of testing my changes on a PR, for example.
First, don't. I wouldn't like to apply validated policies. I mean, you can. So the tools like Caverno mentioned in the previous one can run in test mode, right? You can execute a CLI command that will tell you whether policies would pass validations before without you even really applying them to Kubernetes API. You can also execute dry run, which would give you the same information without really applying those, without applying any resources to the cluster. So if you execute kubectl something, there's dry run from pipelines, it would work, or you can use one of the testing tools like Caverno has Caverno test, I think, or something like that, that will do the same thing.
Okay, third question, is it possible to connect alerting to it?
Yes. So the way how Kubernetes works is that it's all event-based, right? So whenever you attempt to do something, Kubernetes API doesn't do really much. What it does is says, okay, somebody decided to create a deployment, right? Here's an event, and then one or more controllers in a cluster are listening for those events and choosing to do something, right? And that something would be, okay, I'm going to create a deployment, right? You can have easily a controller that listens for events, whichever events you choose, like policy failures or something like that, and just send a message to Slack or wherever you want. You can code it yourself, or you can use something like, I would probably choose Robusta for that. That's the tool of my choice for that, if you don't want to write code yourself. So yes. For anything, nothing to do. This is unrelated with policies, right? You can send alerts on any event in Kubernetes cluster, including policies.
Next question, is these policies apply for dry run?
Is this apply for dry run? I would need to double check. I believe it is. I never do that myself for two reasons. Because if I tend to set all the policies to fail, not to warning, and then if it's not valid, it would fail, and there was never a reason for me to use dry run. So I just made an educated guess that it will probably work. Not 100% sure. I don't do those things.
Okay, would you apply this strategy on staging testing as well? I mean, this requires each type of deployment set needs to be pre-created, and devs are blocked until.
Okay, I need to read it again. Sorry for that. Testing as well. I mean, this requires each type of deployment set needs to be pre-created, and devs are blocked until. I'm not sure why developers would be blocked. If the reference is creating your own custom resource definitions, like the one I created, then yes, developers would be blocked until you created one. But hopefully, you're creating them in a way that it serves many people's needs, not only one person. If you're creating it for that one person, then that one person can create it himself or herself, right? It's similar thing like asking, hey, I have a special need for some service in AWS. Will I be blocked until AWS create it? Yes, right? But once it does, then many people reuse that, and it increases speed in the long run for sure.
Okay, any more questions? Because all are answered. This was answered too.
I'm too fast.
You are too fast.
I'm too fast.
Well, I would encourage you guys, if you're interested, Viktor will be here with us for like one or two more hours, I guess. So you can ask your questions regarding Kubernetes or anything else. Oh, there's one more.
Oh!
So you created a policy for a crossplane composition, but what is stopping users to create deployments directly?
RBAC. RBAC is stopping users to create deployments directly. I mean, in my cluster, no, right now, because I set up the cluster recently, half an hour ago, something like that. But normally you would have, this is nothing, again, this is now nothing to do with Crossplane or custom resource definition. You will have RBAC, right? You will have RBAC that will, no, either you trust everybody in your organization, which is cool, because then you really work in a funky company. And then if you trust everybody, then you trust them not to do things that they shouldn't, right? If you don't trust everybody, the first step, long before policies, is that you can manage these types of resources in those namespaces, and you cannot touch other namespaces. Now, the best RBAC is actually to deny everybody complete access to the cluster. Don't let anybody do anything in the cluster. That's the best possible scenario, because then you would say, okay, I have Argo CD or Flux in my cluster. It is pooling information instead of something like pipelines pushing information to the cluster. Hence, there is no real reason for anybody to access it. And then you can validate it also when creating pull requests. Completely without policies. But then if you do that, you need to really go through every single line anybody ever creates. Policies are still useful, except that they will not be triggered by you doing stuff in a Kubernetes cluster, but by Argo CD going to that same API and trying to apply the same resources. But you need RBAC in any case.
Okay, what happens if a policy changes and the resource becomes violating it because of the change?
So the policy will. So if you change the policy, that policy will be triggered only when you create or update the resource, not simply because resource already exists over there, right? So that will be applicable only to the new resources you create or the attempts to update resources that are already in a cluster, or depending on how you set up policies.
And how would people debug problems if they can't access all resources?
So these days, we don't debug by going to a cluster and doing kubectl exec, going into a pod, praying to whichever deity you're subscribed to, that's the pod you should be looking for and not some other pod, and then doing crazy stuff that you've been doing, right? We debug things by adding tracing to the cluster so that you see the network traffic and you know what's going on, by adding metrics, by shipping logs into some central location, and by also watching events, right? All those things you don't do with kubectl unless you're running a demo cluster like I am. You would have Prometheus, let's say, for metrics, Loki for logs, Jaeger or Grafana Tempo for traces, and whichever way you want to expect logs. I don't know, Mirantis has that lens thingy, for example. I don't use much graphical user interfaces for that, but you don't do that by kubectl exec and going into the container.
Okay, that was the last question. Thanks a lot, Viktor. You had a workshop yesterday at the green stage. Who was there? Workshop? Okay, one person at least. Nice. I would recommend.
He's the only one who didn't lose hope after yesterday's talk. I see. I see where it goes.
Okay, but I hope next year there will be more who are coming to this presentation and also enjoying the workshop. So you got your little gift from Craft Hub. You can have a warm handshake from me. Congrats.
I can give it back to you, and then you give it back to me again.
Yeah, that's cool.
No?
No,
I meant the picture.
Okay, so please give a warm applause to
Thank you.
Viktor, to his presentation.